just going to really quickly do a video of just 4 of the problems from the retest assignment. So the first one I'm going to do is number 1, just because I had a lot of questions about it. So let's do this really quickly. Before I take the derivative, I want to rewrite this so that I have x times, and then I want to write this as 2x minus 3 to the 1/2, because I find that easier to take the derivative of in that form. When I take the derivative, I'm going to be doing a power rule, or I'm sorry, a product rule, because I have this times this. We have a product. So remember the product rules, you take the first times the derivative of the second. Well, the derivative of this is to bring down the half, and then raise the stuff to the negative 1/2. I subtracted by 1, but now I have to multiply by the derivative of stuff, which is 2. So I did first times the derivative of the second plus the second times the derivative of the first. That's just 1. So if I were to kind of multiply this out, I have this 1/2 and this 2. So what I really have is x over the square root of 2x minus 3. Remember, I have a negative exponent, so this goes into the denominator. That 1/2 is my square root, plus 2x minus, square root of 2x minus 3. Now, notice all of my answers are just one fraction, so I need to find a way to get a common denominator, and the best way to do that is just multiply this by square root of 2x minus 3 over the square root of 2x minus 3. Okay. When I do that, I end up with this times this. Well, if I have the square root of something times the square root of the same something, I just take it out of the square root. So my final answer is going to be 3x minus 3 over the square root of 2x minus 3, which is answer choice A. Okay, let's try number 5. At what point on the graph is this function, so this is a curve, it's a quadratic function, at what point will a tangent line be parallel to this line? Well, this is the equation of a line. Let's solve it for y. So we have it in y equals mx plus b form. That will make it easy to figure out what the slope is. So I'm going to subtract 2x on both sides. Now I'm going to divide by negative 4. That means my slope is 1/2. Well, I need to figure out, and for lines to be parallel, their slopes have to be the same, so they go in the same direction and don't intersect. So I need to figure out what the slope, I need to figure out when the slope of this will be 1/2. Well, the slope of this will be 1/2 when the derivative is 1/2. Well, the derivative of this is just x. So I need to figure out when this is equal to 1/2. Well, that's when x is just 1/2. The point, my x coordinate is 1/2. I'm going to find the y coordinate by plugging my x value back into the original function. So I'm going to get 1/2 times 1/2 squared. So my point is going to be 1/2, 1/8. That's number 5. Okay, let's take a look at number 9. I thought this was a kind of just a good question, so let's take a look at it. We need to figure out which of the following could be the graph of the derivative of this function. This is my f function. So let's look at like increasing and decreasing. So notice I'm increasing up to this point and then decreasing, which means here the derivative is positive. Here the derivative is negative. So I'm going to take this point, so kind of like right about here on all of them. Okay. That means everything on this side, or on this side, should be positive. Everything on this side should be negative. Well, everything on this side is positive. Everything on this side is negative. That's good. Everything on this side is positive. Everything on this side is not negative. No good. Everything on this side isn't positive. It's negative. No good. Everything on this side, oh, it's mixed, so that's still no good. Positive, negative. So this is a possible answer. So now we're down to 2 answers, and we have to think of ways to figure out which one it is. So there's a couple ways you can do this. I find thinking about the second derivative the most helpful. So the second derivative of this would be the derivative or the slope here. So for instance, you'll notice from here to here, I'm concave up, which means the second derivative is positive, or in other words, the slope of the derivative function should be positive. So notice from here to here, I'm increasing, the slope is positive. From here to here, roughly, I'm concave down, which tells me my second derivative should be negative, or in other words, the slope of my first derivative should be negative. So notice from here to here, the slope of my first derivative is negative. Okay? And then up. So this is actually the right answer. Let me show you why this one is not the right answer. Notice here we have concave up, concave down, concave up. That means my second derivative changes. Here, the slope of my first derivative is always negative, which would be telling me that my whole function should be concave down, and this whole thing isn't concave down. So that's the way I reasoned through this, but I would hope that at a minimum you could be able to figure out right now how to get between A and E, and if you want to ask me about this in class tomorrow, you can. My last one is number 11. This one I think was one of the other tricky ones on the packet, which is why I wanted to do it for you. It says the radius of a circle is increasing, so I have a circle, and its radius is increasing. At a certain instant, the rate of increase of the area, so I need to do something with area, is numerically equal to twice the rate of increase of the circumference. So I need to do something with circumference. And notice I need the rate of the area and the rate of the circumference, or the rate at which they're changing. So I'm going to take the derivative of both of these. So the derivative of this, remember when we do related rate problems, we're always taking the derivative with respect to time. We're figuring out what's happening over the course of time. So I have the dA dt. I'm going to take the derivative of this. I'm going to get a 2 pi r. We took the derivative of r with respect to t. Over here, I'm going to have dc dt. Now, if this were 2r, the derivative would be 2. Pi is a number, so this is like 6.14. So the derivative is 6.14, but we're going to write that as 2 pi. Okay, so 2 pi dr dt. Coefficient, it's a number, so that's why that stays. We know that the rate at which the area is increasing is twice the rate at which the circumference is increasing. Well, dA dt is this. dC dt is this. And now we're going to solve for r. Well, since we have a dr dt on both sides, we can divide it away. I have a 2 pi on both sides, so I'm left with r is equal to 2. Okay, I hope you found that helpful. I can take some quick questions in class tomorrow, but I hope you guys do great tomorrow. Make sure you're finishing your homework up. Make sure you're doing your test corrections and finishing up this packet here, and I'll see you guys soon.